complicated than that. For this one, we're talking about acids and bases. Acids and bases are sort of like two pairs that like to go together. When an acid and a base come together, they combine to create water. Now, this is called a universal indicator, and what it does is it changes color based on how much acid and or base is in a solution. So if I pour it into our water here, water is neutral on the pH scale. The indicator turns green when it is neutral. Looks pretty green to me, and it goes through the rainbow based on the acid bases. So if something has more base in it, it's going to go more towards blue and purple, and if something has more acid in it, it's going to go towards orange and red. So let's take an acid and see what happens. We're going to take this lemon juice, and we're going to pour it into our... Now you see, if you drink a lot of lemonade or eat a lot of spicy food, your stomach might look like this. You might not feel very good. It's called acid reflux. And you might take a medicine called milk of magnesia. Milk of magnesia is a base. You're going to see, we combine the base with our acid. The base is going to combine with the acid, and they're going to combine to create water. It's going to start to neutralize the acid. And you're going to see our indicator is going to start changing color here. It's going to start going down through the pH scale as the milk of magnesia neutralizes the acid in the lemon juice. Now, the great thing about milk of magnesia is once you take it, you can continue to eat spicy foods, drink acidic beverages, because even if you get a little more acid in your stomach, that base is going to continue to neutralize and will continue to neutralize the acids in your stomach. Alright, is this an example of a physical change or a chemical change? This is a chemical change. Remember, we're combining acids and bases to create water. Alright, so moving on, a little bit of background about me. In addition to being a scientist, I'm also a magician. Would you guys like to see a magic trick? Alright, so here's how it works. I'm going to take a little bit of water. I'm going to pour it into one of our cups here. We have 3 completely identical cups. I'm going to pour a little bit of water into one of them. Now I'm going to mix up the cups. And you guys need to keep your eye on the cup that I put the water in. I'm going to try to trick you, so look carefully. Alright. There's water in this cup. There's none in that cup. There's water in this cup. There's none in that cup. There's water in this cup. There's none in that cup. We're going to try that again, okay? We're going to try that again. Let's just pour the rest of the water in there. I'm going to go extra slow for you guys, so you can pay extra close attention. Don't look away, I might try to trick you. Alright, there's water in this cup. In that cup. Is it in this cup? It's not in that cup. Is it in this cup? It's not in that cup. Now, what's going on? A good magician never reveals their secrets, but I'm not a very good magician. What happened was, before the show, I put a compound in here called sodium polyacrylate. Sodium polyacrylate is very cool because it is highly absorptive. It can absorb up to 300% its own volume in water. It's commonly found in baby diapers, and it's used to create fake snow. So once I poured the water into the cup with the sodium polyacrylate, it got absorbed by the sodium polyacrylate and turned it from a white powder into this sort of gooey substance here. Now, is this a physical change or a chemical change? This is a physical change. We start with sodium polyacrylate in water, and we end with sodium polyacrylate in water. If I were to leave this out in the sun, the water would eventually all evaporate and leave us with the pure sodium polyacrylate. So that is a physical change. Now, for our next experiment, we are going to dim the lights a little bit because we are going to be working with 2 chemicals. One of them is called luminol, and the other is hydrogen peroxide. You guys may have used hydrogen peroxide around the house, maybe to clean wounds and that sort of thing. This is less than 1% concentration of hydrogen peroxide, about 0.15% concentration. You're going to see that it interacts with luminol in a very interesting way. Is this a physical change or a chemical change? This is the chemical change. We see, obviously, a glow, and once the glow goes away, we're going to see a change in color. What's happening is that the hydrogen peroxide, when it interacts with the luminol, it breaks a bond in the molecular structure of luminol and releases a bunch of energy. And that energy gets released in the form of light. And that's the blue glow that we see. And once the blue glow is gone, you'll see it turns into a dark gray color. This is a chemical change. Now, for our next experiment, this is actually probably the coolest experiment, one of the two coolest experiments that we have for our show today. So we're going to do this one twice. I'm just going to do it without any explanation. You're going to see it, and then I'm going to tell you how it works and walk you through it the second time. So all you need to know is we are combining potassium iodate with a solution which is a mixture of sodium bisulfite and starch. Now, this reaction happens pretty quick, so watch closely. If you blink, you will miss it. Now, what's going on here? So, the first thing that happens in this reaction is the potassium iodate turns into iodine. That iodine really wants to bind with the starch in the other solution. However, the sodium bisulfite in the other solution does not want it to bind to the starch. So it sort of pushes it back and forces it to turn back into iodate. However, the sodium bisulfite gets used up. It goes away during that reaction. So that cycle is going to continue to repeat over and over and over again until all of the sodium bisulfite gets used up. And at that point, the iodine is able to bind with the starch, and all the iodine will bind with the starch all at once to create that seemingly instantaneous change in color. So let's watch it again. We're going to combine them, and right now the iodate turns into iodine, is getting pushed back by the bisulfite, which turning back into iodate. That cycle will continue to happen until all of that sodium bisulfite gets used up, at which point the iodine binds with the starch to create that change in color. Alright, is that a chemical change or a physical change? That's obviously a chemical change. You see a change in color. There's also a smell. It's not very good. You'll just have to trust me on that one. And with that, we've come to our grand finale. And you guys are lucky that you stuck around for this. So, this one I need your loves, because we're working with something that is potentially dangerous, not something you want on your skin. We have hydrogen peroxide. Now you guys may be thinking, didn't I just use hydrogen peroxide over here? And I did, but they are different concentrations. So the concentration of this hydrogen peroxide I used over here was 0.15%. Really, really small. This, the hydrogen peroxide you use at home typically is about 3% concentration. This is 30% hydrogen peroxide. Very acidic. It's mixed with a little bit of dish soap. And what happens to the hydrogen peroxide is it wants to turn into oxygen gas. And when I pour it into our large flask here, we're going to see it's going to turn into gas, and that gas is going to get trapped by the bubbles in the soap. Any day now. This reaction takes about 3 to 5 weeks to complete. So, I hope you guys have time. I don't know about you. I gotta go to a Christmas party after work today. I don't have time to wait on this reaction. We need to speed things up. So, in chemistry, when you need to speed things up, you use what's called a catalyst. Catalyst is basically just something you add to a chemical reaction to make it go faster. In our case, our catalyst is potassium iodide. Now, this potassium iodide is not naturally blue. I put some food coloring in it for the aesthetics. But you'll see, when I combine it here, it is going to take this reaction, which normally takes about 3 to 5 weeks, and make it happen in about 3 to 5 seconds. So, are we ready? Here we go. Is this a chemical change or a physical change? This is a chemical change. We see all of our signs up here. We see gas and bubbles. We see a change in color. We see a change in temperature. This foam is extremely hot. The precipitate is formed. Pure iodine is going to be little orange dots all over the foam, and there is a smell. So that is our show today. Thank you all for coming out, and enjoy the rest of your day at Discovery Place.